BGP. Hello and welcome to the part 2 of this lab. So as I said, in this lab we'll do some traffic engineering and we'll play with the route manipulation. So our customer came to us and he said that he wanted traffic from company B to PC3 in company A to flow via virtualmx4 and transit A. And he also said that he wanted the traffic to PC4 from company B to flow via transit B. And he also mentioned that traffic to PC3 should always, doesn't matter what will happen with this link, it should always go to virtualmx4 and then after that to transit A. Also, our customer told us that PC1 should be accessible to company A via transit A, and we should have load balancing between virtualmx2 and virtualmx3 for the traffic to the PC1 from virtualmx1. And PC2 should be accessible to company A via transit B or AS222. So let's go ahead and do that. And let's start with PC3. So what we want to do, we don't have access to transit A or transit B, and we'll have to do all the configuration from PC3 from virtualmx1 side or from company A side. What we can do, we can use the ISPath prepend to inform virtualmx8 that the route to PC3 is not so good, and what we'll do is we will insert the IS number multiple times in ISPath. So when this route to PC3 is shared from virtualmx8 to virtualmx5, for example, and it is compared to the route received from transit A, should do in that way, so it will never accept the route from virtualmx8 and always to prefer the route received from transit A. And in case the transit A will fail, then only after that it should switch the traffic to virtualmx8. So to do that, we will create a policy. So set policy options, policy statement, prepend PC3 from route filter 3.3.3.0/24 exact, then as path prepend, and we'll use as number 444, we'll use it 4 times. Show protocols, display set. Let's apply this policy under transit B as a export policy, and let's commit and jump to virtualmx5 to see if it is receiving or not this route. So if we'll check the routes here, we can see that the route which has been received from virtualmx8 doesn't have the normal AS path. Hence, our policy is not working well here. But I know that this policy is configured correctly. And if I'll check the protocols, I see that it is applied correctly as a export policy. But what actually is happening, Juniper is analyzing the policy from top to down, from top to bottom, which will mean that it will first analyze this policy and it will share the routes to virtualmx8, and it will only after that analyze this policy. But if it had a hit on this policy, it will not move for a specific route to the next one. it will apply the first one. So what we'll do is we'll change the order of the operation. We'll use insert export prepend before PC to BGP. And I'll hit commit, and if I'll go to virtualmx5 and check the route again, I can see that this route would not even be here from virtualmx8. And we have a friend at transit B, and we ask him to show if what we did is working correctly. And he did, he showed us. And after we saw this IS path, we understood that the policy from company A has been applied correctly. And you can see that IS path, this IS path will never be preferred over any of the IS paths. And as you can see, it even shows it is preferring a route from company B instead of this route which is directly received from company A, and this is where it originates. Okay, so far so good. If you go to virtualmx6 and if you'll check the route, we can see that this route is preferred over to go over virtualmx4. You can see this star here, and you can see that the next hop is virtualmx4 interface. But the problem is that if this link will fail, the traffic will go to virtualmx5, to virtualmx3, and after that to PC3. But our customer insisted that every traffic to PC3 will flow only through virtualmx4. And in case the whole device will fail, then it should flow via virtualmx5. So what we'll do, we'll have to create another policy here, show protocols. Let's view the BGP configuration here. And we can use a local preference, which is used inside a autonomous system. And the route which will have the higher local preference will always be elected over any route. So I can go set policy options, policy statement, we'll call it local preference, or we'll call it prefer PC3, and from route filter 3.3.3.0/24 exact, then local preference will be 150. And I can apply this policy inside the company B. So export prefer PC3 and commit. And let's go back to PC6 and see how this route 3.3.3.0. And now it is different. It is only preferred from virtualmx4. And it has the local preference of 150. But what if this link will fail? So I'll deactivate the interface between virtualmx6 and virtualmx4, and I will commit confirm for 1 minute. And let's check again the route. And I can see that now this route is going over virtualmx5. And let's go on virtualmx5 to see this route. And from virtualmx5, it will go to virtualmx4. So our goal is achieved. We are sending this route only through virtualmx4 and only through transit A. If we'll go here, we can trace this route to see what path it is actually taking. So it is going to virtualemx7, to virtualemx6, to virtualemx5, and after that to virtualemx4, to virtualemx2, virtualemx1, and PC3. Meanwhile, our link should go up any minute. Rollback 1, commit, so our link is now up. Let's check where the traffic will go with the link up. And we can see that it is gone through virtualemx7, virtualemx6, virtualemx4, 2, 1, and to PC3. So I could say that this is a success. Now we'll have to solve the PC4 situation. And if you remember, the PC4 should only flow via transit B. So we'll use another policy, and we can use also ASPath prepend to send this ASPath prepend to transit A, so the route will be preferred through virtualemx8. So we'll go with set policy, options, policy statement, prepend PC4. So from route filter 4.4.4.0/24 exact, then ASPath prepend, and we will use our autonomous system a few times. Let's check the BGP protocol configuration, and let's apply this policy as an export policy. Yeah, I know, peer-pend, whatever this means. And I will hit commit. I will go to virtualemx5. Let me check the route to PC4. And this route is going through virtualemx8. And if I'll check run show route 4.4.4.4, I can see that this route will go through virtualemx2, and we have the same situation here. Show protocols, display set. We also need to change the order of the policies. So insert before PC to BGP, commit, and let's jump back to virtualemx4, and I can see that the traffic will go to virtualemx5 and after that to virtualemx8. And if I'll check here, the traffic will go straight to virtualemx5, and I cannot see any traffic which is pointing to transit A. So it will definitely ignore transit A. Now that company A is sharing its routes to company B, let's also do another trace to 4.4.4. And yeah, I can confirm that traffic is flowing exclusively through virtualemx8. Okay, that's very nice. Now let's work on getting the PC1 route through transit 8. We'll do BGP load balancing here, and we'll also need this traffic to flow via virtualemx4. Let's go on virtualemx1 and see the PC1 traffic, which path it is taking. So it is currently taking the path from PC1 from it is learning this route and it is preferred from virtualmx3. And we don't want it just to be learned from one place. We want to perform load balancing using two transit A routers. And we can issue the following command: run show route forwarding table destination 1.1.1. And we can see that it is preferred to go to virtualmx3. And we would need to fix this situation. I will check my notes here, and I would like to take this command here because I don't remember it and I didn't not use it so often. So I will use this. Basically, this will force our interfaces to do load balancing. So we'll enable this configuration here, and we'll go to protocols, display set, and for the transit A, we'll have to enable the BGP multipath, so it will allow two routes to be installed in the same routing table. So multipath, I'll commit this, and if I'll check the route to 1.1.1, now I can see that output looks a little bit different. And if I check the forwarding table, this output also looks a little bit different. And it says that it is using two next hops to deliver the traffic to PC1. AKA, we have our load balancing working. Let's check. We can use trace 1.1.1 and we can see that it is gone through virtualmx3, virtualmx5, and after that to the destination. If I do this again, it also chose on this path, and if I do that again, it chose a different path. When we'll have a lot of traffic generated, it will be equally load balanced between this address and this address, aka VMX2 and VMX3. Okay, but I don't know if you noticed, but if I trace, you can see it is going through virtualmx 4 and 5. But our customer doesn't like this because he said that he would love this traffic to go also through virtualmx 4. So what can we do? We can use med to influence the routes. So since we have company B and we are receiving traffic from transit A, med is the perfect tool for that, because all of our links are from one IS to another IS. So med will be the perfect tool for that. So from the lecture, maybe you remember that the lower med value is preferred over a higher med value. So what we'll do, we'll go to virtualmx4 and check the BGP configuration. And we have transit A here. So what we'll do, we'll yank this line here and metric out. We'll use the metric of 20 for this one, aka a med value of 20, and a med value for this neighbor also of a 20. I will click commit, and we also should remember that we have also virtualmx5. which have links in transit A, and we don't want that transit A to choose virtual MX5. So go to show protocols, display set. We'll go to transit A and we will add metric out of 100. And I want to commit this. And if I go here, run show route, I cannot see med value here, but I can see it very well on virtual MX2. Show route. And if you check, I can see that this link is preferred over virtual MX4, which has a med value of 20, and these routes are pointing to virtual MX4. And if I'll go to virtual MX3 and I will show route, I can see that this route is preferred to virtual MX4 instead of virtual MX5, which have a much higher med value. And this route is also preferred to go to virtual MX4. So our job here is done. The traffic will flow every time only through virtual MX4, and in case something will happen to virtual MX4, it might go to flow over virtual MX5. And the last thing that our customer requested is to access PC2 via IS222 or via transit B. For that, we'll have to create another policy. Yeah, policies are bread and butter in BGP. They are doing almost everything. So set policy options, policy statement, prepend. Yeah, I didn't mention, we also use the prepend here. And we will prepend the policy, the 2222.0/24 route to transit A. So transit A would ignore this route and the traffic will go through VMX8. So prepend PC2 from route filter 2.2.2.0/24 exact, then ISPath prepend, go with 333, 333, 333, 333. Show protocols. Let's apply this policy on transit A, because we don't like transit A for that. Export, prepend, prepend, prepend PC2, and show protocols, display set. Yeah, looks good. Let's go to virtual MX1 and check the route. 1.1.1. Actually, it is 2.2.2. And this route is preferred to go over virtual MX8. But we are still not finished because we have virtual MX5 and we don't want it to accidentally send some traffic via virtual MX3. So we're going to copy this policy, prepend PC2, and we will transfer it to MX5, PC2, ISPath prepend, then ISPath prepend 3333. Show protocols. Let's check our BGP. and we will use this policy on transit A as an export policy. Prepend PC2, I will commit it, and I will go back here and I will check it that this is the only and the best preferred route to company B for the route 2.2.2.0/24. So everything is good, everything is nice. We delivered our project, the customer gave us money, and after a few days the customer came back to us and he said that we should do an acceptance test. And what we need to do is what will happen if we will disconnect these links from company A to transit B, and what will happen with the traffic. Will it work? Because our customer doesn't know BGP and he doesn't know that most probably the routes will be learned via virtualemx 8. So they started the tests. Show interfaces, display set, and the customer disconnected this interface. Disconnected G0011 and G002. So set interfaces G001 disable and G002 disable. Commit confirm for 1 minute. And let's check the route. Now both PC1 and PC2 are accessible via virtualemx 8. And let's go to virtualemx 5 to check the routes received from MX1 or from company A. So this route will be learned, will be accessible via virtualemx 8, and this route will also be accessible via virtualemx 8. And if I go to virtualemx 4 and check the route, this one also will go to virtual. Actually, it will go to virtualemx 2. And this one is going to virtualemx 5. This one, let me check the configuration again here. Show interfaces, display set, show BGP summary. So this session here is idle. So let me do a test. And I will trace 3.3.3.3. So how it is flowing? It is flowing through virtualemx 5, 8, and 1. And 4.4.4 it is going to 5, and after that it is going to 8. I guess all good here. Meanwhile, our interfaces went up, and if I'll ping virtualemx PC3, it should go to the normal path that was engineered to virtualemx 4, transit A, and company A. So far so good. Now what will happen if we'll disable these interfaces here? Actually, what will happen if the virtualemx 8 to company B interface will be disabled? Let's go to virtualemx 5, show interfaces, display set, and we'll deactivate this interface. Set interfaces disable, commit conforms for 1 minute. Let's go to virtualemx 1 and check the routes. So this address here, it is reachable via virtual mix 8, and if I'll go here to PC4 and I will trace 1.1.1, it would look like that it will go through virtual mx 8, because it would look like that I disabled the wrong interface. And I would need to disable the interface. Actually, I have disabled the correct interface. Sorry for that. Rollback 1, show, compare. This interface is disabled. Commit confirmed 1. So if I'll do another trace, now that it is disabled, the traffic will go through transit A, and the traffic to PC2 will go also to transit A. If this interface will go back, then the traffic will go via virtual mx 8, and so after doing these tests, our customer is very pleased, and we have successfully completed our project and our lab for today. Actually, this is the last lab, and I am planning of creating more courses and lectures. So I hope you will be with me in the future. Thank you very much, and you have a nice day or evening or whatever it is. Bye. So on a quick side note, like I said, you can find the video series links in the description, and you can watch these videos chronologically. You can also hire me on Fiverr. I offer consulting and design services, troubleshooting and whatnot. And if you want to follow along with my Udemy courses, you will also find the discount codes in the description. Thank you, and I will see you in the next one.